Hello everyone, my name is Abhishek Jain and welcome back to the tutorial series on a vector database with the help of a Pinecone database. So far, we have understood what is vector database and the related terminology in the part 1. In part 2, we understood how we can create the index, and a last part, which is part 3, where we understood how we can create the embedding, what are the embedding related options, and what all the embedding models are, right? And we also understand how we can upsert or basically store the embedding which we create for the text data to the vector database. In today's video, we're gonna understand some index related manipulation through which we can query the data based on the semantic search and the similarity search, which are the main concept of vector database. So before continuing this video, I would highly recommend you to watch my previous part. If you haven't watched that, you can find the link on the top right of your screen for part 1, part 2, and part 3. And I will also mention those in the description. So without further delay, let's get into the coding part and see how we can manipulate or do the semantic search or the similarity search based on the data we store in the index. Okay, so what I'm going to do now is I'm just going to create another Python file where I will be manipulating. So I'm doing a name manipulating a vector data. And as usual, we're going to copy paste some bare minimum code until this point where we are creating our index. If it is not present, so just to be on a safer side, right? So you can understand this if you will watch my previous videos. Okay. So once we have this index in place, what is the next thing which we have to do? We have already saved the data as well, right? So we have already saved this data. So these are the 19 records which we have in our index, right? The next thing which we're gonna do here is we're gonna create a query. And for doing that, what I have done is I already have a small code created. So we're gonna copy and paste this piece of code. I'm just gonna put here. Okay, so let me explain what this code is doing. So I'm defining a query. This is the query, which we will be using to fetch the record stored in our vector database. So I'm asking what is LangChain used for? And if I just show you the data which we have saved into the DB is, here are the 19 records, right? So whatever LangChain related, you know, the text which will be matching with this query, those are being written. And let's just run this and see how it happens in action. So the very first thing which you have to do for your query is, since vector database is a vector, it understands only vector. So first we have to use the same embedding model which we have used while creating an embedding based on the dimension defined for the index, which is 1024, and we use multilingual E5 large, which is our embedding model. So we have to use the same concept, to just create the vector for our query so that we can feed in the same query to our function, which is going to hit the vector database, does the similarity search, and based on how many records we want as a result, we want to get that. Right? So if you just see, I'm using the same logic where we are using an inference API, embed, and the model name, and the input is query this time. And the parameter is input type query. Here is the difference, because if you just see the code which we have written in embedding, there we have used this embedding parameters where we say input type is passage. But here I'm not saying truncate, but I'm using query, right? So that's the difference, right? So now we can see the embedding. So let's quickly run this code. So it's already exists. Now total token is 13. So this is the dense, which is, this is for our query. So basically we created a vector, basically an embedding that we have to feed in to do the semantic search or the similarity search. And for that, I'm just going to copy this piece of code to save our time, and let me just quickly do the explanation. Okay, so what we are doing, we have created embedding for our query. Now I am making a connection to the index, through this command. We have already seen that in a previous part. Now, through this connection, I am calling this query function where I have to provide a namespace in which, the vector is residing. And now we have this embedding, right? So if I just go and show the print, right? So this is what my embedding is, right? So now what I'm seeing, the data which we have here is this data, so if you just see what I have written here is embedding 0, right? So what's basically what I'm doing is I'm just taking out the first, the element, and I'm just extracting the value. So that values is all only gives us this, right? So whatever the vector representation we have, that is something which we're gonna get from the embedding. Okay, so the stop K3 is we just need the maximum similarity score. Based on the maximum similarity score, we need only 3 records. We can play with this. Include values, whether we want to include values for the result or not, and include metadata, whether we want the metadata. Metadata is nothing but which we just provided when we store the data, right? So if you remember, we have this metadata here, text, topic, and all this stuff, right? Okay, so let's quickly run this and see what happens. Okay, so now here is the response which we get, right? So we get what all values? Vector 11, which says LangChain is a framework that lets developers build application using large language model by chaining together component like memory, prompts, and agents. Make sense? The next one is vector 13, again long chain related. Vector 12 is also long chain. Now we have to see the very important thing here. If you just see the score, this is the similarity score which happens with the help of a metric function which we use for the cosine, right? Here the score is 90% basically. For the second one, the second minimum is the 87%, which is 88, close to 88, 91, and then we have this 88. We can consider that. Based on this, we got 3 records. So you can play with this and you can change to 5, 6, 7, whatever number you want to play with, right? So this is how you can extract the data. The next thing is, if you want to, so I think this is pretty much it, through which we can just get, and if you have been using AI tools like, Olama, where we have a knowledge stack concept, at that point of time is asked, how many chunk you want to, and chunk is actually basically getting extracted based on the similarity score, right? So if you skip 10, then what it does is it just gets the 10 closer similarity score and just assign with your prompt as a context, right? And it can be used in a RAG system as well. Now, this is for how you can do the semantic search and the similarity search. The next thing is the next function which we're gonna see now is, let me just comment this out because we don't need this now any longer. The next piece of function which we're gonna understand is fetch. What we can do with the fetch is we can extract the specific vector information, right? So we need an index. So I'm just gonna copy this. Just put it, right? So what I'm doing now, I am extracting vec1 and vec, right? So once I run this function, right, my response will give me. So let me just, but anyways, I mean, this is how this looks like. So in response, we're gonna have a vectors depending upon how many IDs we are passing, for which we need to extract the vectors information and then the items, right? So let me just print the response here, and you can understand that. And let me just, how I'm iterating, let me just coming up with this. So let's run this one more time. Okay, so this is how the data looks like. And at the end, you can see which I am passing its metadata. Before that, we have these numbers, and fetch, right? We have a namespace, through which namespace, and then we have this vector string, right? So this is what we are utilizing. Inside the vector, we have this JSON object where we have a ID, then the vector object, and then the metadata, right? And that is what we are trying to extract by running this. So if you just see, this is my response, and inside the response we have vectors, and then we have a JSON object. That's the reason I'm using an item. And once we have this item, so we are just dividing that into vector ID and the vector data. So in vector data, we can have a values and the metadata. So here, if you just see, I'm just extracting the first 5 values from the vector. So let me run this, but before running this is not needed anymore. Stop this. Okay, and let's run this so that we can have quick response. Okay, so now we can see vector 10 and vector 1. Vector 10, we have these 5 values. You know, this was our ID, and then this is our metadata, right? There we can see the text. Again, you know, this is just a information which we have printed, right? So we can see here, so we can get extracted ID, values, and metadata, right? Similarly, what we can do, we can delete as well, right? So we can just increase this, and instead of fetch, we can do delete, right? And once we have this, then we can quickly check the steps. We can do this before running this. After this, right? So let's run this one more time. Do this, let me clear this. So we are going to delete those vectors. Okay, so we have 19s. Okay, so probably I need to run this one more time. Let me just run because probably the moment that was not reflecting because we can still see the vector from 19. Now we can see vector from 17, right? So now the two vectors has been deleted. Now, what is next? The next is if I want to change this, right? In that situation, all you need to do is to just create the new embedding the way you did for, you know, original data, right? Here, you can, for example, if you want to just modify the vector 1 and vector 2, right? So you can just copy this piece of code, change the text, and just follow the same thing. Like you can first create the embedding for only these two records, and you can just convert that into these vectors, and then you can just upsert them. So if you want to modify the concept is same, it's just that you have to use the same ID, whatever the text you want to update. So that is how you can update the vector as well. So that's it from my side for this particular video. If you have any feedback and suggestion, please feel free to put that into the comment section, and I would love to incorporate that in my upcoming videos. And as always, thanks for watching this, and stay healthy and keep learning new. One more point, if you really like this video, please give me a thumbs up. And please, if you want to share this with your friends and group, please feel free to do so. And if you haven't subscribed for my channel, please subscribe for our channel as well, because that would be really helpful for me to just keep coming up with the improved content. Thank you.